Okay, so organizations compete on their strategic capabilities. So a data science team is certainly one means of differentiation. We leverage machine learning and big data platforms to extract valuable knowledge from our data. We then manifest that data or that newfound knowledge as algorithms that run on machines for automated decision making. And if we can do this better than our competitors, then we have an advantage. But we also have this other resource called employees, or humans. And these are a different type of processors. Within their heads is a wealth of experience that can really differentiate your company as well. And I'm talking about expert humans. These are people skilled in some domain, say marketing or merchandising or product operations. And if we have better humans than our competitor, then again, we have an advantage. But these two resources, humans and machines, contribute very differently to creating a strategic advantage. Our expert humans, we use them for their cognitive abilities. So much of the information that flows through our systems is, it requires cognition to parse. So if you imagine emails and spreadsheets and documents, these are things that are not easily consumed by machines. They take a human to do it. Other information is just ambient, right? Conversations in a meeting or even cultural norms in the organization. These things are available to humans, but not to machines. We also leverage expert humans for experience, right? So they even sometimes come preloaded with experience when you hire them. And this gives you access to data and judgment that doesn't have to do with your current company, right? You get the benefit of past experience. And also, humans are great at forming relationships with other humans. So this might mean customers. It could also mean suppliers and partners. And it could also mean internally within teams. So for the purposes of this conversation, we're going to refer to that as the art. It can be very instinctive. It's very emotional, right? So this is going to be called art. Over here on the machine side, perhaps the only real skill is that they can perform rote calculations extremely fast and extremely accurate. So this allows them to do all kinds of very creative processing on very large data sets. And using machine learning, you can train them to systematically study structure and behavior. That phrase approximates the very definition of science, so we're going to refer to it as that. So we've got humans providing the art and machines providing the science. And there are many business processes that need both of these. And most organizations do use both, but they use them separately. They solve different problems. But there is a class of problems that call for precisely their combination. So I'm talking about using them together for the same problem, right? And this talk is all about how to combine them, using both those resources within the same system even, to achieve certain goals. Okay, to tell this story, I'm going to talk about the company I work for. I work for Stitch Fix. This is by no means a plug for our consumer business at all, but it does serve as a great example of a process that needs art and science. So we'll talk about this, and with that under our belts, we'll talk about how to generalize this and apply it to business processes that you would probably have in your organizations. So this is a company, has anybody heard of Stitch Fix before? The women have, great. So it is women's clothes, sorry guys, it's women only. So it's e-commerce, but very different. You can buy clothes from us, but if you go to the website, you will not find a single product page or a browse page or even a search box. You're not even going to get recommendations here on the website. At Stitch Fix, the customer does not pick out the clothes. This is the value proposition. There's a lot of people that want a personal shopper. They don't have time to shop for themselves. They don't know what is currently in style. They don't know what looks good on their bodies or is appropriate for their age. So they want help with this. So here's how it works. The customer would come and they'd fill out this style profile. This is where they tell us everything about themselves. Height, age, weight, preferences for fit, preferences for style. They can even write a little free-form note to tell us things about their lifestyle that might be pertinent. They can also leave us a Pinterest pin board of things they found on the internet and they want to share with us of examples of things that they like. Okay, the next thing that's going to happen is an algorithm is going to run, one that leverages all of that information, and it's going to pick 5 things for the customer. And then it's going to send them to the customer, sight unseen. It's not like we show it to them first. We send it. The first time they're going to see this stuff is when they open the box and they can experience it. They can go through the clothes. They can try them on in the privacy of their own home, with their own shoes and wardrobe, with feedback from a loved one. And they only have to, they only pay for what they say. I'm going to keep this stuff. They send the rest back free of charge. We pay shipping both ways. So it's a very, very different model, right? It's a big, bullish bet on algorithms. So algorithms are our single biggest strategic differentiator. Now, algorithms are important to a lot of companies. At Amazon, right, they use it for incremental sales, right? 35% of what they sell is incremental due to their recommendation engines. LinkedIn, half of the connections are made through their recommender system, like people you may know type of thing. And at Netflix, where I spent 6 years, it is the primary vehicle for discovery. But at Stitch Fix, it is everything. 100% of what we sell is through our recommendation algorithms. Everything. So it's extremely important to us. Now, we also have severe penalties if we get things wrong. Those other three companies, Amazon, LinkedIn, Netflix, the incremental cost of a poor recommendation is a shoulder shrug. We've all had them. You get a goofy recommendation, and you maybe buy something for your niece or nephew, and then you get kid recommendations for the rest of the time. It's a shoulder shrug. We move on, and no big deal. At the company, there's no alarm bells going on, all right? It's not like, oh, you got to fix this right now. It's all right, that sucks, but we'll move on. But for us at Stitch Fix, it can be devastating, right? We have the cost of that inventory being out. We got the cost of shipping both ways. And we got the cost of a pissed off customer. To her, this is not a shoulder shrug. She's not laughing about this. She may have been expecting this shipment for some event that she wanted to go to. So we've got to get this right. We have got to be the best in the world at algorithms. It is that important to us. And to do so, we need to leverage all the data and all the processing we can. So this is some data just to show you an example of what we have to face here. This is a customer tuple, so a single customer, and some of the things we know about her. So you can see the size and height and age. Is she a mom? What's her occupation? What city does she live in, et cetera. This is all structured information. These are things with very clear domains of value. And machines are awesome at parsing this stuff. They're awesome at figuring out what it means, how important is it, and things like past purchases. They're able to digest this and figure out things like collaborative filtering. What should we do with this? But look at this other stuff here in yellow. This is a profile note. This is where I mentioned you can, as a customer, you can write in little notes about yourself. And so this customer is saying, my husband is returning home from a tour in Iraq. I would love something special for our first date night in 2 years, okay? You can see how that changes the context of this shipment, right? But it's going to be very difficult for a machine to understand that. Likewise, there's a Pinterest link that customers can leave us. And ingesting this URL is going to return a bunch of images. Things that the customer said, hey, can you take this into account when you prepare my shipment? All right, images, again, are tough to get the real meaning out of with machines. So to leverage all this data, you can see how it's all relevant, and we want to use 100% of it. We're going to need varied resources. The stuff in white we can use machines for. The stuff in yellow is going to be a little more challenging. We're going to need human cognition for that. All right, so this is our styling algorithm, not the real thing, but close enough. It's written out in pseudocode. Now, an algorithm is nothing more than a set of instructions. It's independent from what type of processor is going to execute it. So these first steps up in here have to do with a lot of that structured data we're talking about. And to be honest, what we need here is a lot of rote calculations. So we need to do things like, this is my symbol for matrix factorization. We need to find latent attributes of customers or products that make them desirable. This one is my icon for distance or similarity measures. So if you ever worked with content-based recommender systems, you need to find out how far apart is this product from this customer, right? And you need to do a lot of these types of calculations. Over here is clustering, so you find groups of customers or groups of products that behave similarly, and you can apply learnings at the group level. This is PCA or SVD. You need to find the directions in the data that explain the bulk of the variation. You got logistic regression. You got mixed effects models. So these things amount to literally billions of calculations, billions per customer calculations. So these are best suited for machines. But we're not going to stop there. Again, we have high penalties. This is our core business model. We have to leverage every bit of data and processing we can get our hands on. So we move on and we keep continuing. We take advantage of other pieces of data. I mentioned Pinterest boards and free-form text, right? You see these two examples. This is explicit from our customer. Here's things I like. Please take into consideration when you prepare my shipment. We can't leave that on the table. We can't not look at that. And the note, I already read it out before, that changes the context, right? So we have to leverage these things. But they're very tricky to get right with machines. We do some deep learning and we do process these stuff with machines, but it's only to help our humans. So what's going to happen is these steps get routed out to human processors. These are expert stylists, right? These are not lay tasks. This is not Mechanical Turk. These are experts. These are fashionistas, people skilled with merchandising, and they know what's popular today, right? We have 1,800 of them, and they're ready to take tasks at any moment. So the processing will route a task over. We have this custom interface we built, and it shows up on the screen of one of these stylists. They take the tasks, and they'll take a look at what the machine said with all the output of them. The machines generate recommendations. It shows it to this human stylist alongside this other bits of information. And they say, can you continue on from here? Make sure that these recommendations are consistent with that unstructured data, and they continue their processing, but through humans. Now, we also ask these humans to do two more tasks. We ask them to do some curation. That means look at the set of 5 things that we ultimately select for the customer as a cohesive collection, right? They can't be too incongruent and they can't be too similar. And it turns out the machines are not so great at this. They don't have the co-occurrence in the data to be able to do this. So we keep our inventory very large. And if you think of all the possible combinations of 5 out of the set of inventory we have, it is literally in the trillions. We cannot process this in a fast amount of time, and nor do we even have the co-occurrence to actually see what would happen historically, right? This is an incredibly sparse matrix. Machines also don't have the appreciation for aesthetics. So a human, though, especially a fashionista, can look at this stuff and quickly discern, does this stuff go together or not, right? And they don't have to be outfits, but they have to be similarly themed. So humans are great at this, or at least some humans. I couldn't do it. And lastly, we asked them to foster a relationship with the customer. And this is one-to-one personalization. She saw the note about her husband returning to Iraq, and she's empathizing. She's now writing a note back to the customer saying, oh, wow, that sounds like a special date. Here's some things I picked out, and here's how you can wear them. Right? So this is a deeper connection than you can make through machines. All right, so you can see we use 2 types of resources in our algorithm. It's one algorithm, but it's spread across different processors, machines and humans. So the argument is that art and science, art plus science, right, is better than either one on their own. All right, we have a question?
So, you're basically using prescriptive analytics more than predictive analytics?
Both. There's quite a bit in there. You'd be surprised that so just to put some stuff to rest, we have probably, I would say, it might be the 2nd largest or 3rd largest data science team in the whole Silicon Valley. We have 50 PhDs working on the algorithms, right? So this is not small time stuff. This is big time. And we do augment it, right? So some of the, again, when I say algorithms, I mean on either of those 2 processors. So they are predicting, I don't have the slide in this deck. I do have a different slideshow I talk and I show the predictive quality of this. The richness of the data is unbelievable, how predictive it can be. Now, we'd still need to add human judgment into the mix. So ask me again at the end if I didn't answer your question. Let me try to get through this. So the argument is, or the hypothesis is, art plus science is better than either one on their own. And this is a true statement if both art and science contribute a non-zero amount and they contribute differently. As long as they don't, if they're doing the same thing, then they're not going to be additive, right? But that's the whole point here, is we can be better than either one on their own. And trust me, it does come out this way, right? So if you did machine only, you're going to have a set of stuff that lacks emotion. And if you did human only, you're going to miss out on tons of valuable relationships in the data. Yes? Yeah, I have a slide on that, so hold on. Okay, Now, if you buy into that last slide, you can say, yeah, I can see how adding humans can be better than machines on their own. Or you can make that vice versa. All right, you can buy that. You can nod your head and say, yeah, I get that. But how on earth is this going to scale? That's usually the question I get. And it turns out they scale wonderfully, as long as you couple the expensive humans with some technology. So our engineering team built a very slick UI that allows the humans to interact with the data in a very natural way. And the advantage here is that the machines do all the rote calculations. So they do all the processing, all the sifting, filtering, and qualifying and ranking so that the humans do not have to. We focus their skills or their task on the things that they're great at, such as the curation, fostering relationship, unstructured data. So this interface that I'm speaking of is web-based, so it allows us to tap into a very distributed workforce. They can work anywhere in the US and with very flexible hours. So this allows them to work in parallel, right? So we've parallelized both the machines and the humans, and it works very well. So it's very efficient. I can't tell you the numbers, but you're gonna have to trust me on this, that this is no problem in terms of the cost of the humans. It's not a problem at all, and it scales perfectly linearly, right? So if this is unintuitive, think about a retail store. So a store clerk would be analogous to a stylist, but they're in a store. And in that store, you have to pay the store clerk whether or not there's customers in there, right? If the store's empty, you still got to pay them. Our stylists only work on real tasks for real customers. If we don't have customers, then we don't need the stylist, right? So they're very efficient, meaning they're only working on very productive tasks. And also, a store doesn't scale very well. It scales linearly with employees until a point that you need another store, and then you have a step function change. Here, we have no step functions. It's just straight linear. So we need some number of stylists in proportion of the number of the customers, right? And it's straight linear.
Do the machines select the humans?
Yeah, I have a slide on that. Well, less than a slide, but I will mention that. All right, so scaling is no issue whatsoever. In fact, if you guys familiar with Amazon Web Services, you guys use AWS? All right, so this is where you go. This is called the Amazon console. This is where you go to provision your machine resources. And you have a lot of choices available to you depending on your needs. And you can pick all the machines you need, right? We have another resource available to us. We do use Amazon for machines, but we also have this other thing to tap into a different type of processor, expert humans. So they're elastic as well. Just like the machines, we can provision as many as we want. We can scale them up, down. The humans too. We scale them up, down. Truth be told, we only scale them up so far. We have never had occasion to scale them down, but we could if we needed to. And so we can provision all the human resources we need as well. All right, so here's a schematic of how this all works. Here we have our machines that provide the science side. They're going to do all the rote calculations. Over there, expert humans, they're providing the art, and that's where cognition, curation, relationships come into play. And our logistics system provides some other benefits. So what would happen is a customer is going to request a shipment. We call it a fix. If you hear me say that word, that's what I mean. It's a set of clothes. So to get her shipment, she just merely picks a date from the calendar. When does she want to receive it? That creates this shipment request, and it goes into the queue. Now, we use a queue to coordinate the work between machines and humans because they have very different work styles. Machines are infatigable and very fast. Humans are very slow, and they take breaks. And by the way, either resource can disappear on you at any moment. If you work in the cloud, you know machines can disappear on you, and humans are no exception. They go get coffee, and all of a sudden, what happened? I thought you were going to take that task, right? So you need redundancy, you need failover on both sides. But we use the queue to coordinate their work because they're very different. So what happens first is we take that shipment and we route it over to machines for processing. This is where all the things I mentioned, all those rote calculations happen. Literally billions of calculations happen. And what we do is we take a look at all the inventory we have, and we take a look at this customer and all of our information, and we match it up. Lots of different types of recommendation algorithms. And what they do is they return a rank-ordered list of all the inventory that we can send her along with some information, and we put it back into the queue. Now, we route next to a human. And this is somebody's question. Machines are homogeneous. They're all the same. Just pick one. It's going to be the same. Humans have some differences, right? So we want to pick not just the arbitrary human. We want to pick the best one for this particular task. There may be affinities between the customer's location. Say she lives in Texas. Oh, when we have some stylists in Texas, that might be a better match. Or perhaps moms to moms, or Relationships matter. Oh, wait, this person has, 6 past shipments, and they've all been great. Let's get her to the same stylist she had last time. All these things matter, and so we have an algorithm for that. So we pick one of those humans, and we route the task to her. Now she's going to perform her task doing cognition, curation, relationships. She's ultimately going to narrow this down to exactly 5 items, and she puts it back into the queue when she's done. And then it gets routed over to our logistics system for pick, pack, and ship. They provide the other benefits of home delivery, convenience, that enables discovery and feedback. And so it's about doing more. It's about having art and science and other benefits, and all that adds a lot of value to her. Okay, so we talked about systematizing. Talked about scale, right? And we talked the scale linearly, predictable, and elastic, and very efficiently. Specialization, by focusing each resource on only what they're great at, right? We don't ask humans to perform rote calculations, and we don't ask machines to empathize. By focusing on only what they're great at, we get gains in efficiency through specialization. And there's 2 others that we haven't talked about yet, and I'll have a slide on each. Feedback, and the next is controlled variation. These 2 are a little less obvious, but equally important. So feedback. Somebody asked about this too. All right, so we get feedback. We get great feedback from the customer. This is not your passive thing, well, did she click on this thing? Did she like it? No, this is explicit. She's telling us after she's put it on her body, this clothes, and she stood in front of the mirror, she's telling us exactly what she thought of it. She gives us structured information, by the way, of what did she think of the size, the style, the price, and the fit, and she also writes us a free-form little note if she wants. And that is wonderful information, very precise and very explicit. Anyways, so that informs both the machines and the humans. But this is a costly feedback loop. We have the cost of the shipping, the cost of the inventory, and if we get something wrong, we have the cost of a pissed off customer. But there exists an inner loop that is far less expensive and far quicker. So as machines and humans are doing their work, remember they are both resources in the same system, so they share information. So as they're doing their tasks, they are passively leaving each other information. So we render the set of recommendations to the humans, and they may skip a few things. It may take them longer or a shorter amount of time, and this is all information feedback to make the machines smarter. Likewise, machines can expose biases on the part of the humans, right? Us humans, we make mistakes. We anchor on things, right? And we can mess this stuff up. Machines keep us honest with real feedback, real statistics on the outcomes of our decisions, complete with confidence intervals, p-values, right? And this can actually set us on the right path. If, without this feedback from machines, humans would not learn. So this inner circle is so fast and so inexpensive that the system naturally gets smarter just with usage alone. You don't have to do anything. Just let them keep using it. They get the feedback both ways. Okay, controlled variation. So getting smarter is a great thing, right? You do more of what works and less of what doesn't. But that could lead to a bad outcome in the long run if you reduce variation too much. If you only do what works, you will never learn. And so what you want to do is inject variation in a very controlled way. So you can do this easy enough with machines, right? So let me give an example. Suppose we found that this customer, through her behaviors, she prefers preppy clothes. Right? So we've learned this. Oh, great. Every time we send her preppy, she loves it. Great. So let's keep sending her preppy stuff. But customers' preferences change over time. And if you never explore, you will never pick up on that. Right? And so you need to take some risk once in a while in a very controlled way. You don't want to take a big risk, but you want to inject little bits of variation in order to learn. Now, this is easy enough to do with machines. If you want a more tangible example, think of Google's sponsored search results, right? The sponsored ads, right? This is they do a lot of great variation. When they don't know about a certain advertiser, they just inject it, see how it does. And they keep doing that until they have a judgment on it and say, okay, this thing is not relevant for those keywords. I'm not doing that again, right? So they have to learn this by trial and error. And we have to do the same thing in any business process. So for machines, it's easy enough to do this, right? You can just tell them to do a small proportion of their tasks randomly, or perhaps not randomly, but to favor uncertainty or to favor some risk-taking, right? But you can't do that with humans. You can't ask a human to do something randomly. We are not capable of doing anything randomly. In fact, even if you ask somebody to do something randomly, that's going to raise some suspicion and they're going to behave unnaturally. You do not tell the patient they're being given a placebo. But because they're in the same system together, you can inject the variation through the machines. So you can do a small proportion of your tasks in some risk-favoring way, and you can inject that onto the humans. They're unaware that this is happening, they're getting recommendations, and it's for exploration, and you can do this. Now, it's very important you do this. If you don't do this, you are not going to develop long-term relationships with your customer or long-term learnings. Okay, so that was all very special. This is a very different business model, right? And it's very special and proprietary. But we can generalize these concepts, and they apply to very typical business problems. Business problems like this. These are business processes that exist in most companies. Things like, managing product or content, merchandising, inventory, et cetera. And all these processes can benefit from both art and science, right? Just as an example, so I spent 6 years at Netflix. Netflix produces original content, things like House of Cards, Orange is the New Black. There's a good article in the New Yorker earlier this year about how they produce it, right? So they use data, but not just data, some judgment too. Ted Sarandos, the chief content officer there, said it's about 70% data, 30% judgment. So meaning they use some art. Pricing is another example. There's a lot of good machine learning algorithms to optimize price, but they don't tell the whole story. There can be long-term brand implications if you set price too low or too high. So you need to be aware of this, right? And the machines aren't going to pick it out. It's out of scope for the machines. Humans can add in that piece. Or partner management. Again, I worked at a lot of companies where they have a partner, either affiliate partner or some marketing partner, whatever. By the numbers, you might want to develop a partner scorecard, and by the numbers you can say, God, this partner looks really good. But if you talk to the people who actually interact with that partner, they can tell you a different story. They say, yeah, they're good, but they're a pain in the ass to work with, or they question their ethics, right? So there's an art to this stuff. So all of these can benefit from art and science, much in the same way I depict, right? So you can actually blend them together in the same system. And you should consider doing that when both art and science are required, and the process can benefit from one of these, probably all of these four things, right? So if you have a process that can benefit from art and science, but scale's not an issue, you make the decision once a year, then don't bother, right? So you need to use some judgment on this stuff as well. Do we really need this? But if you decide you need it, you can build the capability. And that's going to require people, process, technology, just like anything else. But with data products, there's some nuance. So I'm going to take you through each of these, starting with people. All right, so people, you need data scientists, but you're going to need to push on them. You want them to be data artists. What I mean by that is you need to lean in on their creativity and their passion. The reason is you can't really tell them what to do. You can't give them a specific problem and give them, oh, here's what I need done. Can you just implement it? It's not going to work because you yourself do not know exactly what you actually need done. This stuff is elusive. You have to learn through trial and error. So it works far better just to give them a general problem. Make sure they understand the business context, and then let them come up with the solution. And because when you come up with your own solution, right, you get attached to things. You put your passion, your creativity into this stuff. It's hard to get passionate about somebody else's idea, but your own, yeah, that you can do. So you're going to have to hire great people, and they're going to have to be extremely diverse in skills. So they're going to need to do things like this. Frame the optimization problem. They're going to need to train and implement algorithms, design systems, process, workflow, write production code, communicate beautifully, et cetera. And if you're beginning to think that this sounds like a unicorn, you are correct. But the good news is they do exist. It's just that those horns are not always visible at early development. So we've had a lot of success with this. What we do is we hire typically PhDs in some quantitative field, very smart people. They don't have all the skills, probably the first two, but not everything else. But we give them big roles with a lot of autonomy, mastery, purpose. And this is all the fuel they need to grow into this. They will learn the rest of that stuff, right? And the first two are kind of, they need them. The rest you can learn, right? And they do. If you give people the space, smart people, to be creative and passionate about what they do, they will pick up all this stuff. Again, you have to have the right people. So you need to screen them well, but they will pick up all stuff. And it's wonderful how well it works. All right, on to process. 3 points to make. So number one is form a strong partnership between the data science team and the functional team. By functional team, I mean marketing or product or merchandising or ops. So you might have a centralized data science team. We do that. But we dedicate people to a function. You're going to work with marketing. Not part-time. Don't do part-time. Don't say you're 50% there and 50% there. Just dedicate. No, this is your thing. Make it beautiful. Right? Dedicate them to the role and never make it a project. These are not projects. Projects implies a finite period of time or some completion date. These are not projects. This is capabilities you're building. You're never going to be done with it. Think of Google's search algorithm. You think they ever say, yeah, I think we're done now. We can pull those resources off and go work on another project? No. They have probably 10 times the number of people working on search now than they did 10 years ago. And 10 years from now, they'll probably have 10 times more than that, right? These things are never done. They want to keep going deeper and deeper and deeper, make it better and better. Number 2, make them accountable. You want to measure them by real metrics. It is not good enough to push code or write algorithms. You have to have a business impact. So really measure them by the impact they make. A good way of doing this is to actually give them the responsibility for the business numbers. So just as one example of it, Stitch Fix, we had a guy that came up with a new inventory algorithm. And so we gave him one category of clothing to manage, to vet out the rest of it so before he can apply it to all the categories. So we gave him one category and said, no, this is yours, so you're accountable for the whole thing. We want him to really feel the weight of the decisions and understand the constraints. And quickly, they figure things out very fast. So just one trivial example is, the output of his algorithm spits out these numbers, and he found himself having to take those numbers and typing them into a system over here so they can be acted upon. And he's, technical people have a very low tolerance for doing rote tasks like that, and so of course he wrote an API that will transfer the data for him, right? So this is, but the business people, they would have just kept copying, pasting, right? They wouldn't have known to ask. So very important that you give them true accountability. And then lastly is make proper practice experimental design. We want to measure the impacts of these things, and it is not sufficient to just say, well, here's what we did before you implemented that algorithm, and here's what we did after. Before and after is not good, right? Other things change at the same time. There may be macroeconomic events, there may be seasonality, whatever. You have to isolate causation with real experimental design, real A/B testing. And
The second point was that that's a little bit controversial because you look at only the impact, not the effort they put.
yeah, you need to, you can do things unprofitably, right? You spend $10 million implementing this thing that gets you $1 million. That's not a good thing. So yeah, but these things, trust me, at scale, these things are usually worth it. I mean, your intuition ahead of time will usually guide you that this is way too costly versus no. These things usually have tremendously high ROI. Okay, on the technology side, 3 things. 1, build custom solutions. This is not something you want to use third-party tools for. If this is your differentiation, this is your means to to compete, you want to do something custom. You want to build it for yourself. If other people can buy the stuff, then how unique is it, right? So these are custom workflows. This is not BI. This is not reporting. These are custom things. So build them yourself. Don't rely on a third-party tool. Number 2, use APIs. This is a great way of decoupling the technology. So the algorithm processing systems and the human applications have very different requirements, right? So they want to be seamless, but they don't have to be the same technology, right? In fact, we use Python on the left and Rails on the right, but they communicate through APIs, and the benefit is they can evolve at their own pace. We make changes on one, it doesn't cause a lot of coordination. Oh, the guys told me time's up. So lastly is investment in a logging pipeline. We want to generate data explicitly for this stuff. As I mentioned, this is the basis for the feedback loop, so don't let it be an afterthought. Do it from the very beginning. You only want to do this if it's going to answer your question. So a capability can be a power for you. This is from a Stanford professor named Hamilton Helmer. He defines a power as a durable leverage that commands higher returns. And you can do that if these 3 things are true. You do something better than your competitor. That's number 1. Number 2, it's not just a little bit better, it's a lot better. It's meaningfully better. And number 3, this is the most important one, it has to be sustainable, hard to copy. If you do something better and it's really a lot better, and your competitor says, yeah, we'll do that too, no good, right? It's just they're gonna copy it and use your benefits. So it has to be hard to copy. I'm gonna let you read that later. That's it. Sorry, I'm out of time because I was late, bad traffic.